In this video, we're going to look at polynomial division. So I'm going to start off just remembering how we did long division way back in the day when we first learned how to do division. So if we look at this problem, 4,953 divided by 24, the thing that helped us is we don't go all the way into the whole 4,000, whatever. I'm just going to look at the 24 and see how does it go into 49. Well, it goes into 49 two times. So I'm going to take 2 times 24 and write that over here. That's 48. And I subtract that. So 49 subtract 48 is 1. Then I bring down the next digit and I get 15. And I say, well, how does 24 go into 15? It doesn't. So I'll put a 0 there. I'll bring down the next number. And I'll say 24 goes into 153, and, well, 25 times 6 is 150, so let's go with 6. So I'll go 6 times 24, and that's going to give me, 24 and 12, 144, and I subtract that, and I get 153 minus 144 is going to be 9. And in the good old days when we first did this, we said our answer was 206 with a remainder of 9. Then later on we had to say, let's go into decimals. I'm going to write this a little different way. I'm left over with 9. I'm dividing by 24. So I'm going to say that answer could also be written as 206. And I'm left with 9/24. We're going to use this same idea to do polynomial division. So now let's look at division with polynomials. So I have 3x to the third minus 5x squared minus 19x plus 4. I'm dividing it by x plus 2. Well, like I did over here, I'm not going to look at the whole polynomial. I'm just going to look at the beginning of it. And with this one, I'm also just going to look at the beginning of that. So I'm going to say, how many times does x go into 3x squared? So I can just do this. 3x to the third divided by x, 3x squared. So I'm going to write 3x squared up here. I'm going to line it up above the x squared because I'm going to line up like terms. Kind of over here, I lined up place values. I'm going to take my 3x times my x plus 2. And that's going to give me 3x cubed plus 6x squared. And again, as I did over here, I have to subtract that value. Well, I'm subtracting that polynomial now, that binomial. So instead of subtracting, I'm going to add the opposite. So that will make that one negative, and that one's negative. So when I add these together, these will cancel. I have negative 5 minus 6. Is a negative 11x squared. And I drop down the next term. And now I've gone from a cubic down to a quadratic. And then I'm going to keep doing the same process. I look at x. I look at, 11x squared. So I do my 11x squared divided by x is going to be a negative 11x. So I'll put that over here. Again, I'm going to line that up on top of my x terms. I'm going to take my negative 11x times my x plus 2. Gives me a negative 11x squared minus 22x. And I'm going to subtract that. Again, I don't like subtracting, so I'm going to add the opposite. These will cancel out, and I'm going to end up with 3x. And I'll bring down the 4. So again, I'll look, how does x go into 3x? Well, 3x over x is going to give me 3, so I'll add 3. I'll take 3 times x plus 2, and I get 3x plus 6. And I subtract that. Now we're going to come along here. Once again, we're going to add the opposite. So the x's cancel out, I have 4 minus 6 is a negative 2. That's my remainder. I'm going to write this as a fraction. So I'm going to say this is plus a negative 2 over x plus 2. And that's my answer. It's pretty much the same method we use with long division of numbers, except in a way I think it's nicer because I'm just looking at leading term by leading term and then seeing how the rest of it carries out. So let's look at another example. Yipes! This one looks worse, but it's actually not. It's just about the same. X to the fourth plus 4x to the third minus 4x squared minus 17x plus 10 divided by x squared plus 3x minus 2. You just remember, I'm going to just stick with first term. Just worry about the leading terms and then see what happens with the rest of it. So I'll start off x to the fourth over x squared is x squared. So I'll put that, line it up over the x squareds, and then I'll take this times x squared. X squared plus x to the fourth, plus 3x to the third, minus 2x squared, and I subtract that. Well, I subtract it by adding the opposite, and I get those go away, and I get 4 minus 3 is x to the third. I got negative 4x squared plus 2x squared minus 2x squared. Bring down the next term, minus 17x. Again, I'm looking at first term. X to the third by x squared is going to be x, so I'll add an x here. I'll take this times x to the third plus 3x squared minus 2x, and I subtract. Again, I'm going to add the opposite, and those will cancel out. We get negative 2 minus 3 is a negative 5x squared minus 15x, and then I'll bring down my 10. So then I go first term. Negative 5x squared divided by x squared is a negative 5. So I'll take negative 5 times x squared, a negative 5 times 3x, a negative 5 times 2, and I subtract that. And I will get plus the opposite, and we'll see this time everything cancels out. I have a remainder of 0. That means that this is actually a factor of this fourth degree polynomial, because I get no remainder when I divide that out. Last thing I just want to let you think about here, I took a fourth degree divided by a second degree. I got a second degree. Over here I took a third degree divided by a first degree. I got a second degree. Just as a double check when you're doing this, if you subtract the degrees of your polynomials you're dividing, you should get the degree of the quotient. That's just the quotient rule with exponents. It still works. It still makes sense.